Hi everybody, this is your science teacher John Walker, and we continue along the same track in physical science and learning about electricity. And I'm in my man cave, as you can kind of see. There's all kinds of. Here's my trusty dog Rilo, who went for a really good walk this morning. Anyway, she's all tired. So electricity, we talked about it just a little bit ago, and we're going to continue. Now, electricity, I'm going to give you a little bit of chemistry background, but you can see that here's the oxygen atom, okay, and inside the nucleus, okay, inside the nucleus are the protons, and the neutrons, and then outside the nucleus are the electrons, okay. And you can see that they're all organized, and the protons and the electrons are equal to each other. Okay, and then over here we have a carbon atom with the protons and neutrons inside the nucleus. And what I'm going to point out is that electricity, okay, electricity is a result of the movement of electrons, from one atom to the next. And I'm going to show you how that takes place. In this particular case, because the protons and the electrons are equal, there is no electrical charge, so nothing really can happen. It's neutral. And also in this one, okay. So when the protons and electrons are equal to each other, okay, in terms of numbers, it's a neutral charge. Now, here's what we're going to go through. We're going to talk about electric charge, and we're going to get into batteries. So this is a really important conversation we're having here, and something that you absolutely need to learn. Okay, so what is an electrical charge? Okay, and here's some of the key terms. Matter that is electrically charged follows these rules. These are absolute rules given in science. Objects with like charges repel each other or push away from each other. So protons are going to push away from each other because they're both positive charge. Okay. Objects with unlike charges attract each other. So electrons are attracted to protons, and that's kind of why they stay, involved in that whole, atom thing. They're attracted to each other. Okay, say no charge, okay, unlike charges attract, okay, like charges repel, and then like charges repel. So here you have two positives repelling each other, two negatives repelling each other. Unlike charges attract, and then if there's no charge whatsoever, there is no attraction one way or the other. So what's a battery? A battery is a series of electrochemical cells that are connected together. And we have wet cells, like your car battery, and deep cycle batteries. Then there are dry cells, like the one that you have in your phone. And then we have electrolyte and then specific gravity. We'll go ahead and explain those just a little bit. Now, here is a wet cell battery. This is what it looks like in your car. Okay, so you have electrolyte over here. Okay, and let's see. So this is where reduction occurs here in the wet cell battery, and this is where oxidation occurs. Okay, now electrolyte produces ions. Okay, and then that's the copper wire, and then here is the light. So you have the connection between the two, so the flow of electrons. So reduction creates a flow of electrons, okay, and when you make that connection here, oxidation occurs, and you have that, okay. And these are either zinc or lead electroanodes, and these are copper or lead sulfate electrocathode. This is positives. Electrolyte is a substance that conducts an electric current when it is dissolved in water. Okay? It conducts an electric current when it is dissolved in water. Ionization is the formation of ions. In other words, when you ionize something, you create either a positive or a negative field. Non-electrolyte, substance that will not conduct electric current when it is dissolved in water. Okay, now oxidation and reduction. We just talked about them. Oxidation, a chemical change in which electrons are lost. Reduction, chemical change in which electrons are gained. Let's go back up here. Okay, there's reduction occurs here. Okay, and so what is reduction? Reduction is when electrons are gained. Okay, here's a dry cell battery. Okay, insulator. Okay, that's what it looks like in your and you have the same thing going on. It's made up of just different substances, but the same oxidation reduction occurs in dry cell batteries just as it does in wet cell batteries. Okay, a conductor. Material through which electric charge can flow easily. Any material that conducts heat or electricity as opposed to an insulator. Okay, a good conductor has high electrical or heat conductivity, and we all know what those are. Copper is a good one. Aluminum, gold, and silver are really good. Okay, all the metals are good conductors. Okay, plastic and rubber are not good conductors. Okay, insulators, material through which electric charge does not easily flow. Any poor conductor of heat, sound, or electricity. Most substances lacking free mobile electrons, such as nonmetals, are electrical or thermal insulators. And we know what those are, like we just talked about them. And they are rubber, plastic, things that don't have good electrons that can move freely. And one of the reasons why, if you take a look at copper, one of the reasons why copper is a good conductor is that it has this one electron in its outer valence shell. Yeah, I know I'm using some extra words, but here's this one lone electron that can move easily from one piece of copper to another. And here's silver. Silver is the same way. And here's gold. Gold's the same way. Okay. And then, okay, so here are some other atoms, and we're going to get into some other material in just a second. We're going to talk about circuits in the next presentation, so stay tuned, and hope you enjoyed this. Hope you're safe, and I'll talk to you soon.